Okay. The first question will start with question in the midterm. Question 14. Equation of the tangent plane at the point for the surface. Question 14. Since it's tangent plane, anytime you see tangent, it means that you need to find derivative. So we need to find derivative with respect to x, with respect to y, with respect to z. Curve itself was z squared. Bring everything over, minus x squared 16, minus y squared 9, minus 1 equals 0. So derivative with respect to x, this here would be minus 2x over 16, everything a constant, so minus x over 8. With respect to y would be minus 2y over 9. With respect to z, it would be 2z. And if you plug the point, you plug point, and the point in this case is 4, 3 minus root 3. So for the first one, at the point would be negative 4 over 8 minus half. The second one would be minus 6 over 9, which is minus 2 over 3. And the last one would be negative 2 root 3. These are the points, and it doesn't matter if you take them positive, negative. I mean, it doesn't really matter because it's pretty much the same thing. So we found the derivative for this. Then you go, that's a constant, that's your vector. So minus half, you start with the minus half, x minus the point. The second one, and y minus the point. And the last one, and z minus the point, equals 0. So you see, if you multiply this whole thing by negative, it would still be the same. So it doesn't matter if you do it, and if you end up with negative or positive, a constant doesn't matter in this case. This is question 14, midterm. Question linear approximation for the function x plus y, x minus y. I'll give you the formula first. Linear approximation xy would be f at the point derivative of x at the point, x minus whatever that x direction of the point, derivative with respect to y at the point, y minus the point. I'll tell you what I mean. First of all, this is the function, and the point is 3, 2. Let's find the derivative first. We need to find the derivative with respect to x, with respect to y. First of all, if I write it, it's x plus y over x minus y. So we do the derivative with respect to x, so we have to apply quotient here. Derivative of, derivative of the top is 1 times the bottom function. Derivative of the bottom function times the top over the bottom squared. So that would be x minus x gone, minus y, so minus 2y x minus y squared. That's if you find the derivative with respect to x. So I'll write it here. The derivative with respect to x is minus 2y x minus y squared. We also need to find the derivative with respect to y. The derivative with respect to y, quotient, derivative of the top is 1 times the bottom function. Derivative of the bottom is minus 1 times the top function over the bottom squared. X plus x, 2x, and the y cancel out. This is the derivative with respect to y. So derivative with respect to y is 2x x minus y squared. So I think you're good with finding the derivatives, nothing special. Now we apply the formula. Formula says, first, you need to plug the point into the function. If you plug the point here, it would be 3 plus 2, 5, and 3 minus 2, 1. Then you need to plug it into the derivative x here. That would be minus 4 and 3 minus 2, 1 squared, 1, times x minus the x of the point, 3. Here, you plug the point into the derivative of y, so that would be 6, bottom is 1, squared, 1, and y minus the y of the point. So your linear function is 5 minus 4x plus 12, 6y minus 12. Cancel, cancel. So it's 5 minus 4x plus 6y. This is your linear approximation equation for, or in this case. Good? So we go to the next one. We did this function. You can also plug the point if you like, plug the 3 and the 2, but you don't need to, it would give you 5. But they expect an equation for this, and this is how you do it. The last question is question 17. Question 17, you're given this function f of xy and it's e to the y squared minus x squared. You need to find the critical and verify and see, do the process and see if it's a saddle point, if it's not a saddle point, see all the necessary work. Now, to do this, I'll take it one step at a time, find the derivative with respect to x. Well, if you take this inside, this is like y squared ey, x squared ey. The derivative with respect to x, that's a constant. Here would be minus 2x ey. We find the derivative with respect to y. We have to apply product rule. Derivative of this, 2y times the second function. Derivative of the second function times the first. Derivative of this with respect to y would be x squared ey. Now, it seems a little bit complicated. what you need to do is you need to make them both equal 0 and see if you can solve the system. To do this, I'm going to consider this one. If I want to consider this one, I'll 2y e to the y, ey, y squared, x squared, ey equals 0. So if I want to consider this, what I can do is I can take ey common factor. So it's 2y, y squared minus x squared equals 0. Now, from the first one, you have 2x times ey equals 0. E to the y can never be 0. That means from the first one, x must be 0. Now, we know x is 0. From here, this again, e to the y can never be 0. We know x is 0, so now this whole thing must be 0. And since x is 0 already, so you take y as a common factor, you have a 2 plus y left. So either y is 0 or minus 2. So you have 2 points. 0, 0, and 0, minus 2. These 2 points are critical, and we need to verify to know exactly if they're maximum, minimum, or a saddle point. Okay, to do this, we have to, I want to keep this because I'm going to find more derivatives now. So finding the critical we did, now we need to verify. To do this, we need to find fxx, fyy, and fxy. So we need to find the derivative of this with respect to x again. A constant x would be the constant. The derivative with respect to y, product rule here. Derivative of the first one times the second function times the first. Product rule again, derivative of the first one times the second function times the first. And a constant, this would be a sum. This one means whatever you did in terms of x, do in terms of y. The derivative of this with respect to y would be itself. So we found all the different derivatives. Now, to know if it's a saddle point or if it's a critical really or whatever, I'm gonna apply this formula. Now the formula says you need to do a d, and it's the derivative of xx, yy, xy squared. So I'll try first point, the 0, 0. If I plug the 0, 0 here, it would be negative 2. If I plug the 0, 0 here, it would be 2, that's a 0, that's a 0, that's a 0, that's a 0, so it's 2. If I plug the 0 here, and you need to square this, if I plug 0 here, it would be 0 squared, so that's minus 4. If you get a number when you do this, and this number is less than 0, that means that this point 0, 0, because here this point is a saddle point. If you try now point 0, minus 2, So we applied the D formula. 0 minus 2 here would be minus 2e to the minus 2. 0 minus 2 here would be a lot of crap. It would be 2e to the minus 2 minus 4e to the minus 2 and 4e to the minus 2 and minus 4e to the minus 2. All of this is the second derivative. Minus, if you put the 0 minus 2 here, which is 0. If you do this, this cancels with this, and this times this would be 4e to the minus 4 eventually. And this number, I don't care, is positive, more than 0. That means that this point is critical, and it's either maximum or minimum, but the question wasn't asked to find if it's a maximum. If it's a critical, so this one is in fact critical, so it's a max or a min. This one is a saddle point. Again, I'm not sure if this is required for you for the midterm. It's good to know. Just have a quick look at it, and we'll confirm later if it is or not. Okay, good luck, people.